All right, so operations with functions. You'll be happy to know that there's no graphing in this lesson. All right, so to start with, we're going to talk about sum, difference, product, and quotient. So if you're adding two functions, subtracting two functions, multiplying two functions, dividing two functions. So this green box is really just showing you two different notations. Make sure that you recognize both to mean the same thing. And then if you're dividing, you're putting a polynomial in the denominator usually, which is going to create some kind of domain issue that you have to discuss. All right, so if they're polynomials, then it's really easy. This wants me to do g of 3 plus f of 3. So if I take my g function and I plug 3 in for x, and then I take my f function and I plug 3 in for x, and then I add those two values. So this is 9 minus 3, 6, plus 0, so we would get 6. All right, this is asking us to take the f of x function and subtract the g of x function. So that means we're going to do x minus 3 minus x squared minus x. Now, parentheses aren't necessary here, but here there absolutely are to make sure that you remember to distribute that. So this is really x minus 3 minus x squared plus x. So negative x squared plus 2x minus 3. All right, number 3 wants us to do f of negative 2 times g of negative 2. So that means we want to do negative 2 minus 3 and get a number, and then multiply that by negative 2 squared minus negative 2. So this would be negative 5, and then we'll multiply that by this is 4, and that comes plus 2, so 6. So we would get negative 30. And then number 4 wants us to do f of 4 divided by g of 4. So f of 4 would be 4 minus 3. G of 4 would be 4 squared minus 4. So you get 1 over 16 minus 4, so 1/12. All right, so these, not all polynomials, which sometimes makes it easier and sometimes makes it more difficult. That didn't say, yeah, sorry, this whole like domain thing, I was thinking it might have said that on the previous one, but it didn't. All right, so if I want to just do f plus g, that means I want to do the square root of x plus x minus 4. If you can combine something, do so, but you can't. So then we want the domain. So we got to think, is there anything happening here that causes an issue? Well, there's really only two issues that you could have at this point. There are others, but we haven't learned the things that cause the other issues. So the only two issues that you're going to run into at this stage of the game are you cannot take the square root of a negative. And the other one is you cannot divide by 0. So if you have a square root or you have a variable in the denominator, those are the only two times you're going to have an issue. So here, you can't take the square root of a negative. So our domain would be anything from 0 to infinity. We just have to exclude negative numbers. All right, number 6 wants us to do f minus h. All right, so we know for this guy, we have to be 0 to infinity. Well, for this one, we can't have a 0 in the denominator. So x minus 2 can't be 0, so x can't be 2. All right, so if I take these two ideas and I marry them together, I want anything from 0 to infinity, but I can't be 2. So our domain is going to go from 0 to 2, and then pick back up at 2 and go to infinity from there. All right, so the next one, they want us to take f and multiply by h. So then we can clean that up a little. We can make it one fraction, but it has the same two issues that this guy did. So it has the same domain. We can go anywhere from 0 to 2. As long as we hop over 2, we can keep on going to infinity. All right, so then this last one, they want g over f. So they want x minus 4 over the square root of x. All right, so we know the square root of x, if it was just the square root of x, would go from 0 to infinity. But since it's in the denominator, we can't have 0. So the domain would be 0 to infinity with a parenthesis, because we just have to say don't include 0 this time because it's in the denominator. All right, so this last one, if we want this f plus this g, this x isn't special. It's not in a square root. It's not in a denominator. There's no issue there. What's happening is here, we can't take the square root of a negative. So if we take what's inside the radical and say that must be greater than or equal to 0, and then solve that, so subtract 2 from both sides, then we need to have a way of saying x must be greater than or equal to negative 2. So our domain is anything from negative 2 to infinity. And we can include the negative 2 here because 0 is okay as long as that square root is not in the denominator. All right. So these are asking the same kind of questions. They just give you your functions in set notation. All right, so we want f of negative 3 minus g of negative 3. Well, f of negative 3 is 1. G of negative 3 is 2. 1 minus 2 is negative 1. This is saying do f of 2 times g of 2. F of 2 is 0. G of 2 is 6. So 0 times 6 is 0. All right, so now we want f times g and its domain. All right, so the domain is the x's that the two functions have in common, and those are the only ones that we can actually use. So I'm actually going to find the domain first. So the domain, what x's do they have in common? They both have negative 3, and they both have 2. So then our new function, f times g, we're going to have an x value of negative 3, and then we're going to multiply 1 times 2 and get 2. So that's that ordered pair. And then when x is 2, we multiply those y values, 0 times 6, and we get 0. And that is our new function. All right, so f plus g. So again, the domain is going to be negative 3, 2, because those are the x's they have in common. And then f plus g, same thing. We're going to get an ordered pair with negative 3. We're going to get an ordered pair with 2 as our x's. And we just have to figure out what the new y's are going to be if we add them together. So 1 plus 2 gives me 3. 0 plus 6 gives me 6. All right. So I'm actually going to take all of this and kind of slide it down where I can, no, I'm not, because I can't see it if I do that. Let's see, I'm going to put it here so maybe I can see both at the same time. All right, so g minus f. So same thing, g and f are going to still have a domain of a negative 3, 2, if you try to put them together, because those are the x's that they have in common. But keep the order in mind. So when we do g minus f, now we have to say when x is negative 3, the y, we have to start with g and subtract f. So 2 minus 1 gives me 1. And then when x is 2, 6 minus 0 gives me 6. All right, so 15, we're going to be slightly different. I'm going to go ahead and say that we assume the domain is negative 3, 2, but I'm pretty sure that we end up having to take one of those away. Because if I do g over f, when I say x is negative 3, then if I do the g functions y over the f functions y, 2 over 1 is 2. But if I go try to do it for the 2, if I try to say there's an ordered pair where x is 2, then I get 6 divided by 0, which is undefined. So that point doesn't actually work out. So we only get this one ordered pair of negative 3, 2. So the only number in our domain, the only x that works, is the negative 3. All right, so composition of functions. This is missing some letters. Composition of functions is when you put one function into another. So f of g is how you read this or this. It's two ways of writing the same thing. Again, be familiar with both because you may see both. This says g of f. This means put f into g. This means I said that backwards, sorry. This means put g into f. This one means put f into g. All right, so number 16. If I do g of f, that means that I'm going to write down the g function and plug the x with the f function. So the g function says take the square root of something, and that something gets replaced with the whole f function. All right, I'll come back and talk about domain in a minute. We're just going to talk about can we do a composition. So h of f means take your h function that says 1 over something, but plug the something with this whole f function. Right? 18, we want h of f of g. So if there's more than one, you've really got to work from the back forward. So we're going to put g into f and then take that and put it into h. So if we put g into f, that means that we have the square root of x minus 2. This went here. Then we can take what f of g is equal to and plug that into the h function. So that means we ultimately end up with 1 over the square root of x minus 2. All right, now going back to state the domain. We've handled one that looked like this before. We need to know when this is greater than or equal to 0. So we need to know x is greater than or equal to 2. That's the domain. So we can say from 2 to infinity. For this one, remember you can't divide by 0, so this can't be 0, which means x cannot be 2. So for the domain, we can say all real numbers except for 2. So actually set notation that just says this would be easier, but in interval notation, it would be negative infinity to 2, jump over 2, and go to infinity. And then for this one, we know that we cannot have negatives. So just from, this is going to be like a two-part thing. So just from this, we know x has to be greater than or equal to 0. And then from the whole thing, I know that this is not allowed to be 0. So the square root of x cannot be 2, which means that x cannot be 4. Because if you square both sides, then you get 4. All right, so if we're saying that we need to be 0 or bigger, but not 4, then putting that together, the domain is going to go from 0 to 4, jump over 4, and continue on to infinity. Remember, brackets mean it's included, parentheses mean that it's not. So that's why I put parentheses on the 4, because we're saying that you go all the way up to 4, but don't be 4. And then we pick up on the other side of 4 and keep going. All right, so evaluating a composition, you're going to find the inside and then plug it into the outside. So f of -1 is what we're going to do first. So 3 times -1 minus 1 is going to give us what? -3 minus 1, so -4. So then we can find g of -4. So that would be -4 squared plus 1. So 16 plus 1, 17 is our answer. All right, h of f of w. So f of w is what we're going to start with. And all that is take your f function and replace the x with the w. That's a minus, not a plus. And then you're going to do h of that. So that means we get 3w minus 1 plus 1 over 3. So 3w over 3. So just w. All right, here again, 3 goes into g. Start at the back and work your way forward is how this is going to work. So we need g of 3 to start with. So 3 squared plus 1 gives me 10. Then we can do f of 10. So 3 times 10 minus 1, so 29. And then h of 29. So 29 plus 1 over 3, so 10. All right, so again, the trick with these is work from the back to the front. All right. All right, these are kind of the hardest to understand, like 23. 22 is not too bad. If we do g of 1, then we get 2. Plug in a 1, you get 2. Plug in 1, you get 2. So then f of 2. For the f function, if I plug in 2, I get 0. So ultimately, 0 is the answer. All right, if I want to write a new function for g of f, then I have to think about I'm plugging f into g. So we're going to start with the f function, end up with the g function. So on the f function, if I start with -3, so hold on. So f of -3 gives me 1. So then I have to go do g of 1 and see what that gives me. So g of 1 gives me 2. So that means the first ordered pair in g of f is -3, 2. -3 ultimately ends in 2. All right, so go back to your next ordered pair. F of 0 would give me 4. Go over to the g function. G of 4 gives me 0. So I have an ordered pair of 0 ultimately gives 0. All right, so the next f of 2 gives me 0. Then I go to the g function and I plug in 0, but I can't because there's no x value of 0. So since that doesn't work, these are the only two ordered pairs that I have. So g of f is going to be the set of ordered pairs -3, 2, 0, 0. All right. All right, so in Math Excel, they're going to give you a couple of questions that look like this. It's really just a composition in disguise. They want you to use the two functions to write y as a function of x. So what they're really saying is I want it to say y equals some stuff done to x, but right now it's some stuff done to t. But they tell you that t is x minus 1, so you can just plug that in here. So it'd be x minus 1 squared minus 3. And then I'm pretty sure they want it simplified in Math Excel. So remember that we're going to write this down twice, multiply it all out, and combine like terms. That should obviously be a 3. So this is what they would want to see in Math Excel. That should not be a 3. That should be a 2. Why do I second guess myself? 1 minus 3. That should be a 2. All right. I believe that's all. Let me know if you have questions.